done that, you can have your plan approved and you may start building. Does that make sense?
You know, and we can also push the load with the wheel and axle.
I think it was called duct tape.
It's the wire in the face.
I know. Okay, one of us watches it, one of us reads it, and one of us helps us.
How about we don't need a front axle? All we need is a back axle because all we need to do is lift up the front.
It's a car!
Yes, Ben.
Chris thinks of it on the way. Did we bend over? Yeah, we did. Wow. Good job. By the effects of the pulley, the car went backwards.
Yep.
Wow.
I need for everybody to reset whatever they're using and head to a spot that is away from the testing area because we are going to test. What was the total score for moving the load by hand? So we said it was 10 and 75 hundredths. This is for design 1. And we're all going to test because I want you to see everybody's designs and see what works in other people's and what doesn't work. There you go. So now it's floating here. That took to get here 3.25 newtons. Okay? From here, I need to pull it over, which took, about 1.5. And then from here, it took about 275. So they got 9.25. So theirs is better. So theirs drops in there. Okay, to get it there, it took about 2. To lift it up, took about 5.75. That bending down doesn't count because remember with a pulley, I don't have to. Didn't have to bend over. Did I have to pull upward? No. I pulled down, so -2. So they got 5.75. All right, let's have Brooks group set up over here. Ryan, then the worker pulls the rope. So 0.25. The worker then attaches the potatoes. So they have to bend over to attach them. So we're at 0.25. They then pull down. And again, I could keep pulling, but I just want to keep my accurate reading on the spring scale. So that would be 3. And then 0.5. Okay, so it's a total of 3.75. I had to bend over.
Pull down.
I did not have to pull upward. I did not have to push, pull down. So you got +2, -2. You get a total of 3.75. You have the next 20 minutes to fill out your create page and then to fill out your improve page. We're going to fill out all our paperwork to improve. We're going to do our improvements tomorrow.
We're going to change our design completely. We had the incline plan and it wasn't very sturdy. So we're taking that out and we're putting in pulley. We're kind of using less duct tape.
Well, we're definitely going to keep the wheel and axle, that's for sure. It really works.
To start, we should use the double pulley instead.
I think you're right. Maybe we should try a double pulley lever.
Double pulley would work better because it uses less force, but the single pulley just pulls it up, but it uses the same amount of force as you would lift it with hand.
We plan to make it less complicated, to do it time after time. We plan to try and make the wheel and axle bigger to put more potato sacks on it, so then we can make it easier to get it to the loading gun.
What happened when you tested your subsystem design?
It was too much weight
It was
from where we had the pull from. The thing is, it's kind of hard because we have to use a lever. We don't really have a choice. I think we should use the pulley. Because listen, when I think we put the lever right there. We put the lever right there. We don't have to bring it up all the way. We only have to put it up the ground this much.
My goal is to test at about 10:30, 10:35. So that's about 20 to 25 minutes. Does that seem realistic? All right, no one should be talking. Everybody should be watching. We're testing. All right, so it's up the top. Fell off a little bit. They got 6.5. Did I have to bend over? No. Did I have to pull upward? No. Did I have to push below? No. Did I pull downward? Yes. So the -2, they got 4.5. What'd you get the first time?
5.25.
So you improved. Please. I want to see your first score and your second score written down. Okay? I pull downward and twist. It moves it over. That was 3 newtons. Then I take and pull it up the ramp for 5 newtons. I had 3 and 5, which is a total of 8. I had to bend over, pull upward, pull down. So +4 -2. So they had a total of 10. So it is less. And you improved compared to your original design because you had 20. So they did improve. I will say the lever is probably the harder one because if we could make a bigger lever, you could use it differently, right?
Yeah.
Okay. Okay, so they averaged 3.5. Okay, so it's 3.5, and I had to pull upward is the only ergonomics concern. So they had 5.5. What was your original? 7.7 and 2,500. So they've definitely come down. I need you in your science seat so we can do our closing paperwork as engineers would do. So what you need to do now is you are going to write your final report to the president of the potato chip factory. You are going to say who it's from. So you're going to put your real name. So I would put Mr. Harkins, Industrial, and I'm going to leave it nice and big so you can see engineer. So explain why we were asked to improve it. Talk about the ergonomics. You should choose our subsystem because you can say it's the best, but why is it the best? Is there someone who is willing to read their final report?
Mary Kate, industrial engineer. Subject is improvement to loading dock subsystem. The problems for the worker for using the subsystems were they were hurting their backs by they had to bend down and pick the boxes of potatoes up and then walk them to the loading dock. You should choose our subsystem because the wheels with the pulley connected to it, you don't have to use a lot of force. You're just pulling it for the most part.
My name is Ryan. I'm an industrial engineer. The problem for the workers using the loading dock subsystem is hurting their backs, knees, and arms. Our subsystem design makes work easier for the factory by giving them less pain and making work easier. You should choose our subsystem design because it worked easy for our group, and also it takes less newtons, but it trades force for distance.
Brooke, industrial engineer, April 14th, 2011. Subject, improving the loading dock subsystem. The problems for the workers using the loading dock subsystem were they had to bend over, drag their potatoes, and lift them up, which hurt their backs, knees, etc. Plus, they weren't efficient. And here's my diagram. It's just a double pulley attached to a wheel and axle. Lift the wheel and axle up more easier. Our subsystem design makes work easier for the factory workers by using less force and trading it for distance. We improve the efficiency too. You should choose our subsystem design because you get more work done without hurting the workers.
I like this lesson because the kids are always engaged, they're always working really hard, they're understanding what an industrial engineer is doing, and they really get a grasp of it, as well as they have fun doing it. And management-wise, it's chaotic because there's a lot of noise, a lot of building, but at the same time, they're always on task, and so that's kind of the great thing about it. You have to set the ground rules immediately at the beginning, so some tips I would have is you set the ground rules immediately. So when I was testing, kids needed to be frozen and watching the testing being done. That way, everybody was paying attention, everybody was recording. You need to be very careful because sometimes kids, especially even 5th graders, don't realize if they have 3 boards taped together, they can't spin around, so it's kind of just showing the safety procedures and the ways they should be moving materials and what they should be doing with materials. Just clear ground rules are really what I think help make this lesson run. I think the hardest part, I find that some students really struggle with the lever and how to incorporate that in. I think they really wish that they could have a bigger lever or a longer arm or a different lever, so I think size-wise the lever is challenging. And I think that they sometimes will struggle if they have just this one idea of what they have to do. So sometimes they might need a little direction to help it in. But overall, I don't think they struggle a lot. I think they really are challenged and really like to work with this one. I think the challenging thing is providing enough testing stations for them. So if they all want to use a pulley, having enough pulleys available for them to be able to test with that. That's I think where the challenge comes in for them, is being able to test their design without having to do the one testing station. I find the biggest helpful hint is if you can schedule a day where you do all of your testing for lesson 4, do all your plans, and then let them spend the day doing it. It's easier because it's less with the materials, because you do have to have the materials set up, you do have to have your room rearranged. So if you can schedule it so it's one day and have it done in that one day, it makes for a fun day, and 2, it makes it easier on you because then your room's only kind of rearranged for one day. I actually really like this unit because of the final report they have to write. They have to really think about what they've done, and they came out really well this time.